This episode of Fluid Power Forum is sponsored by Endeavor AI. Endeavor AI automates order entry, quoting, and the quote-to-cash process. Win more, sell more, and save time, all without adding headcount. Head to endeavor.ai to learn more. This episode of Fluid Power Forum is sponsored by IFP Motion Solutions Incorporated, the leader at engineering electronics into fluid power distribution. IFP spans the 13 central states from Minnesota to Texas. For more information, visit ifpusa.com. Welcome to Fluid Power Forum, a podcast of the National Fluid Power Association. I'm your host, Eric Lanke, and it's my job to interview interesting people who are moving fluid power technology forward. And today we're recording live from the CONEXPO-CON trade show in Las Vegas, Nevada. Fluid Power Forum is a podcast that showcases interesting and innovative uses of fluid power. And one of the reasons we're here at CONEXPO-CON is that the electrification of mobile equipment is one of the most innovative spaces we've ever seen for fluid power. Once thought to be the death knell for hydraulics on these machines, electrification is actually driving shocking degrees of innovation, as the onboard hydraulics, still needed for its power-dense actuation of work functions, becomes more efficient, becomes quieter, and is increasingly hybridized with electrical systems and electronic controls. So much so that we're often asking the question, is that still hydraulics? So to help me answer that question, I have three presenters from the NFPA Advanced Hydraulics Conference that we've been conducting here at CONEXPO. We have Barun Acharya of Parker Hannifin. At the end, we have Joe Budden of Danfoss Power Solutions. And in the middle, we have Philippe Reynolds of Poclain Hydraulics. Gentlemen, welcome to Fluid Power Forum. Say hello. Round of applause. Now, all three of your presentations at the technology conference deal with this broader theme and trend of electrification. Not just electrifying the prime mover on a piece of mobile equipment, but often electrifying the hydraulic system itself by hybridizing it, as I said, with electrical components or controls. So I'm hoping the first thing we can do is I'm going to ask each of you in turn to give us a quick summary of your presentation. Barun has already given his presentation today. I know the other two are scheduled for tomorrow. But focus on what is it about the new fluid power or hydraulic system that's different because of this hybridizing technologies that you're doing? How is it different from traditional hydraulic solutions? So Barun, can we start with you? You presented on a smart hybrid architecture for off-highway machines. And I saw your presentation. You actually had a nice slide that summarized what a traditional hydraulic system is and what some of the changes are. So can you summarize some of that for us?
Absolutely. First of all, thank you for having this, and thanks for having us for this panel discussion. As far as my presentation earlier today, I talked about hybrid architectures. Basically, my thesis was there is a big portion in the markets that we serve where fully electric doesn't make sense. Frankly, the reason is the constraint is not the cost of the motors. The constraint is the cost of the batteries. So the thesis is what makes most sense is to cut down the size of the batteries. And the way you do that is doing hybrids. So to me, the future is hybrids for a big portion of the markets that we work on. So, and then after that, I talked about three different applications for hybrids, if you would. So the first example was a downsizing of the engine. That was for an electric hybrid backhoe loader. So basically what we did is we cut down the size of the engine from 75 horsepower to below 50 horsepower. And then we came up with a method to run it in different modes. So we could run it in full electric mode. And then the size of the battery was kept at around 10 kilowatt hour. And the reason was, again, to keep the cost down. And then what we did is once you have this battery and you know how expensive it is, it's very important that you maintain the efficiency downstream. So you use the battery power in a proper way. So what we did then was downstream the hydraulic system efficiency. We went from a fixed open center system to a variable pump, what we call a variable flow open center system. So basically it was a open center valve with some modifications, and then a variable piston pump, which was a load sense control with the EDC control on top. And the reason was to do some adaptive controls. So that was my first example. The second example was very similar, but instead of engine downsizing, it was about hydraulics downsizing. And this was for a side loader, refuse truck. And we cut down the size of the pump from 140 cc to 65 cc. And then the third and final example was for compact construction, where we changed the steering from orbitrol system to steer-by-wire system. And the traction system, we eliminated the hydrostat altogether and replaced with a simple gear pump / motor. So basically the idea was you keep the hydraulics downstream as is with the ICE system, but you make it smarter. You have more sensors built in, you have controls built in, and then the main difference is in an IC engine, the engine runs at a fixed speed, but with the electric motor driving the pumps, you can vary the speed in milliseconds. So the idea is how do you use that so you don't create the overflow or the overpressurization, which ultimately results in losses.
Great, thank you, Barun. Joe, can I ask you to go next? I think your presentation is on intelligent e-hydraulic systems. So kind of the same question. Give us a quick summary of that, and especially like what's new about the hydraulic system as a result.
Yeah, absolutely. Thank you for having me, Eric. This is a great topic for us to discuss in the fluid power side of the world. My presentation in a nutshell is piece 4 of an argument that I think Danfoss is bringing to the conference this week. You've heard the first 2 presentations from Danfoss today. One was on a conversion to a full BEV 30-ton excavator and the challenges that you run into from a system architecture as a result of that. You heard the second one today, which was a ground-up remaking of an electrified backhoe loader. So that way we can understand the challenges that our customers might face that we won't typically run into as a component supplier. We also have a presentation tomorrow by another team member, which is talking about how the world is getting more complex, and we're talking about more and more advanced type of system architectures. And so the presentation is to talk about how do you select the correct one for your application? How do you know if you should be thinking about a serial hybrid, a parallel hybrid, a BEV, a conventional internal combustion engine? Are you talking about, a load sense system, or are you talking about an electronic displacement control? There are a lot of choices, and we're to the point where these are starting to get overwhelming for our OEM customers. So we need to be the experts in the room to talk about this. And then probably the least impressive of the 4 presentations is actually mine, which is I'm so glad we have you on the panel then, Joe. Which is talking a bit about how we're seeing challenges in the electrification world through real-world examples that we've had, startups that we've run into, things that if you are coming from a hydraulics background into an EV application or a hybrid application, maybe you haven't thought about simple things like, maybe back EMF, or things like torque ripple that you wouldn't expect to have a significant impact on your system that now becomes much more fundamental, as well as things like NVH concerns that when you have an internal combustion engine haven't been as historically present as they are in the electrification space. So hopefully that whets the appetite.
Yeah, great. Thank you for that summary. And Philippe, we'll go to you third. Again, your presentation is tomorrow. I think it's on a new electric wheel hub for construction machines, if my information is correct.
Yeah, that's correct.
What's novel about that system?
Yeah, actually, Poclain is leading the transmission systems based on wheel motors, and since there is a trend to electrification, we worked also on all types of potential systems, wheel-driven transmissions. And when electrifying the wheels, we came to the conclusion that setting up such kind of system can be complex in terms of integration, in terms of controlling the transmission in all soil conditions and work conditions of the machines. And so we worked on the design of what we call an EDU, electronic drive unit, which integrates all the functions and technologies into one mechatronic solution, which is highly easy to integrate in terms of connections, in terms of communication to the rest of the system. Kind of plug-and-play solution, basically. So this is what we'll go in terms of presentation to see what are the benefits and advantages of such a design for the future.
Right. So I'm hearing that the changes kind of universally are less about the traditional hydraulics and the more about how we're controlling the hydraulics or how we're driving the hydraulics. I'm the least engineering educated person on the stage right now, so forgive me if I stumble through that. But that's kind of what I heard. Am I getting that right? Would you say?
Yeah, definitely. I think if we look at, I would say the trends, we see that, and at Poclain again, we are, let's say, trying to get technology agnostic. So when we say making electric or zero emission vehicles or more efficient vehicles, we are not just only thinking about pure electrification, right, but also the hybridization of electric and hydraulics together. And when it comes to, let's say, electrifying with electro-hydraulics, the vehicles, basically you need to change the sizing paradigm of the transmissions. Historically, we've always been sizing the transmissions more on power, trying to really reach the highest power requirement, and that was really what was sizing the transmission. The trend now is really more to think about, energy efficiency, CO2 emissions, and sizing the complete transmissions in terms of energy consumption rather than pure power, while still delivering the expected performance that the end users expect to have.
Excellent. So it's funny, NFPA has long taken the position that an electric-powered or an electronically controlled fluid power system is still a fluid power system. So all of the hybridizing components or technologies that go into that expanded system, if you want to think about it that way, are part of fluid power and part of the fluid power industry. So I'm curious, we have three great companies represented here on the stage. I'm curious about the approach that your companies may be taking to that, because for some of our member companies, those are brand new things that they're dealing with. Some others have deeper expertise in those areas. So how are you each onboarding those new technologies into your engineering or production processes? Or how are you organizing your company to better handle that? And Joe, can we start with you from Danfoss's perspective?
Yeah, I think this is a great question. And I think this is really reflective of a changing expectation of our OEM customers in the market. The expectation is that we are system solution providers that are experts on their applications at this point. When you think about it in those terms, this becomes somewhat of a natural evolution then. When you start thinking about the expectation of electrification to be part of your pump system, you start to see that you need to have experts in the electrification area, in the hydraulic area, in the application area, and in the controls area that can tie all of these pieces together. So for Danfoss, the way that we're specifically addressing this is to take a one Danfoss approach. You have Editron, which is our electronic components. You have our software team, which they do a lot of the controls programming for us. You have our open circuit pumps and our gear pump teams, right? They're all separate teams, but at the end of the day, the way Danfoss is organized is we're organized as a group that can take all of these different pieces, put them together into one cohesive system that our customers come to expect, and deliver that. And I think one strong thing that we do to prove that beyond simply putting them together is we put our money where our mouth is. Danfoss is pretty widely known for our application development centers, where we take real vehicles, we strip them down, we put in new Danfoss solutions on real vehicles that our customers can come and drive, and it reduces some of the risk for them, right? It's one thing to see in a PowerPoint that this system should work well, and a simulation that our efficiency gain should be XYZ. But unfortunately, you have the former test engineer sitting up here on the stage with you who used to be in the dirt and didn't believe any of the data until I saw it on the pressure transducer or flow meter to see the reality.
Great. Philippe, can we go to you next? Talk about how Poclain is dealing with some of these technological challenges.
Yeah, I would say we are not very original compared to what Joe just said. I think we are going exactly the same path where we have competence centers, obviously, for each of the components. We expanded actually our competences through acquisitions, because when you talk about electronic or electric transmissions, you need to master also e-motor control and power electronics. You need to master as well e-motor design and production. So we made acquisitions in those fields, but I think one of the key changes is really to position oneself at the level of the system engineering rather than product design. And you have first to think about the system, the application, understand the duty cycle, what are the power requirements, torque requirements on a continuous level, on a peak level, what is the thermal behavior expected from the system. And you need to have all these input data at system level or machine level so that you can really design the system that is, I would say, answering the requirements as best as possible within a cost and performance envelope, which is also an input from the customer side. And then you need to basically raise the level of competence of your company on system engineering, being capable of embracing system compliance, functional safety, dysfunctional management, calibration, and testing of vehicles, as you said, modifying the vehicles, let's say internally on demo machines to test, the systems that you are developing, making them bulletproof. So this is all what we are going through right now. On specific applications where we are leading, I would say, the way in terms of current transmission systems in hydraulics, developing the systems of tomorrow to support the transition to zero emission.
I like the way you said you have to raise the systems level engineering of your company as if that's a simple thing to do, right? I mean, I'm imagining that
it's not so simple.
It's a challenge, isn't it?
Yes, yeah. It's a daily task.
Exactly. Great. Barun, how about Parker Hannifin? How is Parker dealing with some of these changes?
Yeah, we're very original, so our approach is very different.
Yeah.
Not at all. So I think ours started at the very top leadership. So basically, they identified electrification as a secular trend. And then what they did is at the very top level, we used to have hydraulics group and automation group. They combined them and they call it the motion systems group at the top level. And then on the systems team, they created electrification growth team that I'm part of. And basically, it's a bunch of systems engineers and who have knowledge about hydraulic systems, electric machines, and also controls. Basically, the idea is the lines between, the separation, we had the silos, right. That's gone, so that's blurry. And that's what our team is supposed to do. And then last but not least, last September, we acquired a company called Curtis Instruments. That was $1 billion acquisition. So again, back to the point, they're putting the money where where the mouth is or whatever. And so there's a significant investment by Parker. In spite of the delay in the S-curve we see in the electrification realm, there's a lot of investment made by top leadership.
Did I hear that correctly? I heard Barun and Philippe both mention acquisitions. Joe, do you talk about acquisitions? Is that something Danfoss is working on?
That's an excellent question. Yeah, I mean, Editron,
yes.
the organization came from a series of acquisitions, right? So, of course, it's something we're actively looking at and making sure that we're staying current and leading in the market.
It's one of the ways to bring new technologies into a company.
Course.
Clearly,
Yep.
Yeah, right. All right, well, this is clearly a time of significant change and innovation for the fluid power industry, as we've been hearing. I guess my last question for the panel is, I'm hoping that they can each give us a glimpse of the near-term future as they may see it. And I think the way to ground this, I'll ask you to respond to two quick questions. First, what is the most important machine level trend that is responsible for these changes that we're seeing in the fluid power industry? And then what new innovations will your company be bringing online to address that challenge? And I think, Philippe, we'd like to start with you and Poclain, if we can.
Yeah, thanks for asking these questions. I think the main drivers are first productivity, efficiency, and operator experience. I think those are the three key drivers for us that we see that can drive the electrification or more electric subsystems into vehicles. Then the way we analyze the market on machines and trends is basically there is no one solution that fits all. The market is highly fragmented in terms of types of machines, power usage, and duty cycles. So you really need to have a fragmented approach. But if we try and summarize it, probably compact and light duty equipment, we think in terms of architecture, we'll head towards battery electric vehicles because there the battery capacities and technologies are present and I would say almost affordable. When you move to higher power machines, heavier machines, as Barun said, we think that hybrid solutions are probably the right, I would say, current architectures because that serves the, let's say, gains in efficiencies, CO2 reductions, while still giving the range on the machine that is expected. In terms of technological trends, we think midterm we will see higher and higher voltages because fast charging is typically something that is today a kind of issue in terms of duty cycles and usage of the machine in a daily operation. So moving from 4896 systems to 400 or 800 volt systems. That combined with the hybridization of the systems, especially on the auxiliary functions or work functions of the machines, we think that there will be more and more requirements for high voltage, low power solutions within a finer segmentation than what you can currently find on the market. And also the final trend that we are identifying is more and more integrated units for easy integration and time to market because the architecture will be more complex. So to make still the development of the machine efficient, you need solutions that are easy to integrate and to interact with the ecosystem in the machine. So that's what are driving our, let's say, R&D work right now. And the last point is being a partner that can really, support on all the aspects of the integration from, I would say, technological performance to product compliance.
Excellent. Barun, from Parker's point of view, what are the major trends that are driving this innovation and what's coming next for Parker innovation-wise?
Yeah, I think in terms of major trends, I think Philippe mentioned most of them. It's really a combination of the emissions regulations that's driving us, combined with also what the operators, the fleet managers, they demand. It's not just the emission regulations, it's total cost of ownership matters, ROI matters, and so that's the other thing that's driving it. So whatever solutions we provide, it has to make sense financially at the end of the day. In terms of what Parker is doing, I would recommend you to visit the Parker booth at CONEXPO in the South Hall. I don't know the booth number, but anyway. So there's lots of new products coming.
It's hard to miss, Barun, actually. So, yeah.
So we have new motors, new inverters, in the GVI, the GMI series that's being, you can go to the Parker booth, look at it. And then in terms of just a quick thing, what we're working on would be, the motor, the inverter, rather than just being, doing the commutation for the PMAC motor, it's going to be more than that. It's going to have the built-in pump controls as well. So that's kind of is the next thing that we're working on. And with the acquisition of Curtis and the vehicle control language that they have, very, very excited from a system standpoint, what we can do.
Fantastic. And Joe, from Danfoss's point of view?
Man, I was really happy when I got to go first and sound really smart on the last question with these guys.
You're bringing it home right
yeah,
now, Joe.
Honestly, I think you guys nailed it. Like most of the trends you've already touched on. I think maybe just to re-emphasize one and state a second one that's coming online now. The expectation that's shifting from OEMs, from us being parts guys to systems guys to vehicle guys to experts of their systems. Their resources are limited, and they're leaning on us harder every day to act as their experts on their systems, to be able to answer complex, difficult questions about what's going on their machines that just fundamentally sometimes they don't necessarily know the answer to. And that trend I don't see going away. I see it continuing to grow. The only other thing that I had on my list, and I intentionally put together a really long list so I'd have something for third, is I agree with everything you guys have talked about. You've talked about the different enabled technologies that we're starting to see come online, and the only thing I think that we didn't specifically speak to here is autonomy. And electrification is definitely enabler to autonomy. When you have more precise control, when you can see what's going on with your prime mover in a different way, it allows you to think about your system differently. There are more degrees of freedom when you talk about an electric system than when you're talking about an internal combustion engine system. So that's one other thing that I think is becoming enabled because of this technology, and I think that's also going to drive more technology, and it's going to become more and more fundamental as the market develops in this space.
Well said. So we have the rare opportunity to actually get questions from a live audience on the podcast, and so not to put anybody on the spot, but are there any questions for our distinguished panel from the audience? Yes, go ahead, Mark. If I can, let me repeat the question for the recording. So it's about the evolution of actuator technologies, perhaps being displaced by electric solutions instead of fluid power driven actuators. So comments on that?
Yeah, I would say this is something that we're monitoring very carefully, and like we're actively investing in some of these areas as well that we think there's potential. ELAs, electric linear actuators, are definitely something that we're starting to see. People have explored with them. I would say the initial approach of replace everything hydraulic with everything electric that was out there for a few minutes has maybe not borne as much fruit as as some others were hoping. The power density of hydraulics still remains a fantastic value proposition that's very difficult to compete against. We're certainly not out of business yet.
Philippe or Barun, any comments on that? Barun?
Yeah. I think if you're interested in that, one of my colleagues, Dale Vanderlaan, is going to talk about it tomorrow. So he has done a trade study on electromechanical actuators versus hydraulics. But my 2 cents is, a 350 bar hydraulic cylinder with the power density, very hard to replace that. And it's not just the power density; it's also the shock ability, that the hydraulics can withstand. Those are very hard to replace. However, there are applications where it makes sense. Like if you want to position something, the duty cycle is low, I think it totally makes sense to eliminate, because after all, why go from mechanical to hydraulics domain? If you can just, go from electric directly to mechanical domain, why go to the hydraulic domain at all is the point. So you eliminate all those losses if you do that. And there are niche applications, for example, like a greens mower. So if you are working on the greens, so you can't afford to have a hydraulic leak. So those are the applications where electromechanical actuators make sense.
All right, well, that is the end of our time, so that is going to wrap things up for this episode of Fluid Power Forum. Please join me in thanking our great panelists, Barun Acharya of Parker Hannifin, Joe Budden of Danfoss Power Solutions, and Philippe Reynolds of Poclain Hydraulics. Please give them a round of applause. And thanks to all of you for joining us for this live recording here in Las Vegas. That certainly has been an exciting exploration of the new technological space that hydraulics is moving into and thriving in, I think. So thank you all for attending.
Thank you, Eric.
All right, well, that is going to wrap things up for this episode of Fluid Power Forum. My thanks to Barun Acharya, Joe Budden, and Philippe Reynolds, who have been my guests on this special episode. If you'd like to connect with any of them, the best way to do that is via email, and we will put a link to their email addresses in the show notes for this episode. Remember, if you like our podcast, and we hope you do, please follow us on LinkedIn. You'll get all kinds of updates there. We're there at the National Fluid Power Association. And make sure to keep sharing those interesting and innovative uses of fluid power with our hashtag #OnlyFluidPowerCan. We truly want to hear from you about the kind of topics you'd like to hear addressed on the show. Fluid Power Forum is a podcast of the National Fluid Power Association. I'm your host, Eric Lanke, reminding you to join us next time in the forum.